Okay, so before we start, we are just going to have a little bit of a refresh over here. And I just want you to do those 3 questions just to get our heads back into the game. Find the equation of the circle with that center and that radius, 2 and 5 and 4, and then find the center and the radius of the following circles. Just do those for me in 2 minutes. Post your answers in the chat as soon as you're ready. And then we're going to kick off with our tangents. By the way, while you are thinking about these questions, all the recordings of our previous lessons are available on the website. So you can watch those recordings and do the quizzes. They are also available for you to do. Just head on over to our website. Everything is there. Thanks, Johannes. I see Johannes has posted an answer to, I think, what is this question 2A. Just going to label them. This is 1. And let's make this 2. And then B. Yes, don't leave out question 1A. Okay, so we are finding the equation of the circle in question 1A with the given center and the radius. And then in question 2, we're finding the center and the radius from the given equation. Pop your answers in the chat. This is just to warm up and get us thinking. Let's do 1 more minute. Well done, everybody who's posting their answers. Remember, maths is only learned by doing. So just try. Even if you're not sure, just give it a go. Really, nothing bad is going to happen if you do that. Okay. 1 more minute, and then we're going to have to head on over to our new lesson, our new content for tonight. Okay, let's have a look at question 1a, the equation of the circle. The equation of the circle with a center, we always write it as x minus a squared plus y minus b squared equals r squared. A and B are the coordinates of the center. So for this particular one, that's going to be minus 2 squared, y minus 5 squared. And then r squared is the radius, which is 4 squared, that's 16. Give yourself a big tick if you got that one right. Okay. Then the center and the radius of the following circles. So the center for 2a is going to be 2 and 7. And that's C. And the radius is going to be the square root of 36, which is 6. Give yourself another fat tick if you got that one right. And then the center for this one is going to be 9 and minus 3. And radius is 1. Square root of 1 will always just be 1. So another fat tick if you got that one right. Okay, well done. That was just to get us going and to make us think again about our circles. Tonight we are going to find the tangent to a circle. So to do that, we need to bear in mind a few important things. So the first thing is that a tangent to a circle is perpendicular to the radius of the circle at the point of contact. So if you've done circle geometry, then you might know this as the tan-rad theorem. So the tan-rad theorem states exactly that the tangent is perpendicular to the radius. So let's highlight that 90-degree angle very brightly, because that really is the key that unlocks the whole puzzle. Because if that is 90 degrees and the tangent is perpendicular to the radius, then we need to use our knowledge of perpendicular lines and their gradients. And if you remember from what we did in the first lesson or so, at the start of this course, we said that if lines are perpendicular, then the gradient of the one line times the gradient of the other line, so M1 times M2, must give me -1. There's two important things you have to hold here while you are doing this, is that the tangent is perpendicular to the radius, and that the gradient of the radius times the gradient of the tangent must give you -1. So, for instance, if my gradient of OP is this line here, if that gradient is 2, let me actually also color match it so that it's in green. If that gradient is 2, then the gradient of PQ will be -1/2, because the two multiplied together must give me -1. Okay, very important, and write that down as a note. If you haven't done so already, or if you haven't done, if you don't remember this from doing this at school or anything like that, but that really is the most important thing, is that the radius and the tangent are perpendicular, and that means that the gradients multiplied together must give you -1. So how did we get from the 2 to the -1/2 very quickly? Because that was very quick. So what we do is, so if that gradient is 2/1, then what we do is we flip it over and we change the sign. So flip and change, basically. So flip and change, flip the gradient over, change the sign. So that's going to give me 1/2, change the sign, make it negative. So that is one way that you can remember this whole thing with the gradients that multiply together give you -1. And we can check it. 2/1 times -1/2. Yes, that definitely gives me -1. Okay, so those lines are perpendicular. Okay, now let's do an actual question so that we can see how all of this works. Okay, so let's have a look at this question. Find the equation of the tangent to the circle with m at c 3 minus 5. With center m and c, I think that's meant to say, and c 3 and minus 5. Okay, so the first thing we do is to put down that 90-degree angle because of the radius and the tangent being perpendicular. So AB is perpendicular to MC. We can calculate the gradient of MC. So let's do that now. Gradient of MC. That we just do with change in Y over change in X. So we can go 1 minus 5 and 1 minus 3. Okay, so the first thing you do is work out, you can write that as a little step here, work out the gradient of the radius, because MC will be the radius. To calculate or work out the gradient of the radius. So 1 minus 5 is 6, and 1 minus 3 is going to be minus 2. That gives me minus 3. Yes, Mbali, I see you have a question. You can unmute.
She hasn't quite connected her mic. So it might be she can't hear. She either can't hear us, or you need to type your question in the chat if you can.
Yeah, feel free to type questions in the chat tab. Okay, so that's the gradient of MC. Now we're going to determine the gradient of the tangent, which is AB. And to find the gradient of that tangent of AB, we are just going to use our M1 times M2 equal to minus 1 sort of formula or concept. Or we can just say if the radius, the gradient of the radius is minus 3, then I can take the minus 3. So at the moment it's minus 3 over 1. I can flip it over and change the sign. So therefore, the gradient of AB will be 1 over 3. And you can check it. Does 1 over 3 times minus 3 give you minus 1? Yes, it does. Okay. And then lastly, we're going to determine the equation of the tangent. So the tangent is a straight line, y equals mx plus c. We have already determined what the gradient is, so that is a third, x plus c. So now we're going to sub in the point where the tangent touches, which is this point here, c. So we're going to sub in that point. So we sub c, 3, and minus 5. So that we can solve for c, right? So c is the point, but we're also solving for c in the equation. So don't get confused with your c's. So that is not 3. Y is minus 5. Y is minus 5. X is 3. And that gives me a third times 3 is 1 plus C. And then C is minus 6. Let's put it all together. Y is equal to a third X minus 6. And that is our final answer. Phew. Okay, let's just run through that again. Okay, so the important concept is that the tangent is perpendicular to the radius. So if you can work out the gradient of the radius, then you can find the gradient of the tangent because they will be perpendicular. So that's where you start. You calculate the gradient of MC in this case. That is the gradient of the radius. We use our standard gradient formula to do that. Y2 minus Y1 over X2 minus X1. We calculated that. We get the gradient is minus 3. Then to determine the gradient of AB, we use the fact that the lines are perpendicular to determine that gradient. So we take the minus 3, flip and change. So we do the reciprocal, or we do the, instead of 3 over 1, we do 1 over 3, and we change the sign. No, Zama, I'm not on mute, eh? Hey, Miss Coco, can you hear me?
Yeah, I hear you fine, ma'am. I have no issues.
Sorry, Zama says I'm on mute, so, but I don't think I am.
I will check with Zama.
Okay, thank you. And then we determine finally the full equation of the tangent. So we say that the gradient is 1 over 3. We calculated it in step 2. And then we sub in our point where the line is tangent to the circle, 3 and minus 5. And we solve for C, our y-intercept, and we put all of that together. And there we go. That's the equation of our tangent to the circle. Okay, right. Can I get a thumbs up from everyone if you're good with that, if that made sense, or a thumbs down if it didn't. We are going to do more, so just want to get a sense how everyone's doing with this so far. Well done. Okay, well done, everybody. Okay, lots of thumbs up. Please be honest if it's a thumbs down for you. Okay, wonderful. Wonderful. Okay, great. Thanks, everybody. Let's move on and do a bit of practice. Okay, so super quickly wants to just here's the third part again. So after we've determined the gradient of the tangent, we are going to now do the complete equation of the tangent. So if y is mx plus c, we have already found what m is. So that's where this comes from here. So if this is my m, and this is my M over there. Yes, please post your question in the chat, just like the other learners are doing. Don't be shy to ask questions. Just post them in the chat and I'll pick them up, or Ms. Coco will pick them up. Okay, so there's my gradient. That's my M in my equation. Then I sub in point C. So point C is over here on the sketch. That's where the line touches. That's where the tangent actually touches the circle. So that's why we're going to substitute that into our equation. And then we find our y-intercept over here. And we just round it off nicely by putting everything together in the equation. Okay, but let's do another one. I think it'll help if we just get stuck in and start practicing. Okay, now, one big tip is that if the question is given to you in a test or exam or in your homework, wherever you're doing it, if it is given to you without a sketch, draw a little sketch. Okay, it does make it easier if you have a little sketch to refer to. So, for instance, in this case, we are given the equation of the circle and it says find the equation of the tangent or tangents to the circle in each of the following cases. So, there's my circle. This is the circle. And this is the point where the tangent touches. So, I would suggest right now, quickly take 30 seconds and just make a rough sketch of the circle with the center and the point where the tangent is touching the circle, 0 and 3, and then draw your tangent in as well. That's all good, Masood. We are sorry to see you go, but I hope you'll be back on Thursday. Okay. Just make a quick sketch of the whole situation for yourself. I'm not going to reveal my sketch yet. You must try and make a sketch yourself. Okay, let's see. Here's my sketch. Okay, so there's the circle with the tangent. The center is at 2 and -1. You could have named that point C or O. That's fine, as long as you have it more or less in the right place. And it's also fine to do a little scale like this, 1, 2, 3, 4, 5, etc. But yeah, okay, so there's my circle. Okay, Mbali, we're going to do exactly the same thing now. So I think just listen again, because we are going to do exactly the same thing again now in this question. Okay, so the coordinates of this point here is 0 and 3. And there's my tangent in red. Okay,
I must say,
so
your sketch is looking very, very professional. You've got a very good hand there. Like, you're so good.
I cannot take credit for the sketch, but thanks. Okay, so let's go back to our steps. We start off, we have to work out the gradient of the radius. Okay, so the radius is going to be this line here, right? From the center to where the tangent touches the circle. That's the radius. So let's work out the gradient of that. And I'm going to name this point T for touch. So M for the center and T for where the tangent touches the circle. So the gradient of MT is the change in y over the change in x, so 3 minus 1 over 0 minus 2. That gives me 3 minus 1, that's going to give me 4 over -2. 4 divided by -2 is -2. Okay, so that's the gradient of the radius. Our next step is to determine the gradient of the tangent. So the gradient of the tangent we're going to take the gradient of the radius, flip it over, and change the sign. So the gradient of the tangent is a half. Lastly, we use y equals mx plus c to find the full equation of the tangent. I already have my m, my gradient, so that's a half. And I sub in my point where the line is tangent to the circle. And we sub that in so that we can solve for c. So y is 3 and x is 0, and we are solving for c. So c is going to be 3. Put it all together, write down the equation with all the information. That's a half x plus 3. Okay, so steps again. Gradient of the radius, gradient of the tangent, equation of the tangent. Sub in the point where the tangent touches the circle. Okay, right. Here's one more. I want you to try this one on your own. So I'm going to leave you alone for about 3 minutes to do this. Draw your sketch, because none of these are sketches, so make your own little sketch for it. And then determine the equation of the tangent to this circle at the point -2, -1. Okay, off you go. Zakuna, is there a particular part of the question that you don't understand? We are finding the equation of the tangent to the circle. So first we find the gradient of the tangent, which is what we did in this step over here. Then we use the fact that the tangent and the radius, they are perpendicular. So we can use that to find the gradient of the tangent. And then we find the equation of the tangent by subbing in the gradient and the point where the tangent touches the circle. And the next question, we're doing the same. We are determining the equation of the tangent to the circle at the point -2 and -1. Best is to draw a little sketch to represent the situation. Draw your circle with that point as the center and the point -2 and -1. Whenever you're ready, pop your answer into the chat. Okay, some people are quick. We've got Johannes already with an answer. We've got Kayla with an answer. Taniko with an answer. Well done, everybody. Well done. Everything has disappeared off my screen again, which always gives me a slight, small, tiny heart attack. But then it comes back. Remember, your sketch doesn't have to be 100% accurate or to scale. It's just a basic representation. It's always helpful to have the visual representation of the problem, especially in analytical geometry and geometry, anything visual. It's good to have that in front of you. Okay, we've got some superstars here who have done this already. Belinda and Tamika, well done. Katlejo, Amanda. Looks like I can go home, Miss Coco. These kids know what's going on.
Yeah. The stuff, they're so good. I see you guys.
I am home, by the way. Okay. I forgot that I'm home. Okay, so we're going to start by calculating the gradient of the radius. So we're going to say minus 2 minus 1 over 1 minus 2. So that's minus 2 plus 1 is minus 1. And then 1 minus 2 is plus 2, so that's 3. So the gradient of the radius is minus 1 over 3. That can help us with the gradient of the tangent, which we're going to flip and change. So that'll be 3. Katlejo's asking, ma'am, about the diagram, is it always necessary to draw it? It's not necessary. It's not like you're going to get marks for it, but it does help to make it easier to sort of visualize and not make a mistake. So my recommendation is to draw a diagram, but if you can do it with art, then go for it. Okay, and now we're going to do the equation of the tangent. So y is mx plus c. Our gradient is 3. And we're going to sub in our tangent point, which is this one here, minus 2 and minus 1. So y is minus 1, x is minus 2, and that gives me minus 6 plus c, and that's 5, and that's c. And putting it all together, that's 3x plus 5. Excellent. Well done to all of you who got it right the first time. Excellent stuff. Good stuff. Yep, definitely on fire. Okay, now with that one, yeah, let's do one more. It does, Aisha. Just look at our question. The center is at 1 and minus 2. So x minus 1 to the power of 2 does become 1, not minus 1. Remember, you take it out the bracket, it changes sign, and if you put it into the bracket, it's always the opposite sign when we do the coordinates. Yeah, thanks, Ms. Coco. Rightio, one last one for this evening before we go. Here it is. I'm going to give you 2 more minutes again to do this. Draw your sketch, or if it's your preference not to, that's fine too. But for those of you who are maybe still struggling a little bit, I would draw a sketch. And then we just go through those 3 steps of finding the equation of the tangent. Nico's working super fast this evening. Yes, Nkosinati, you have a question?
Yes, I do have a question.
Yes, let's hear it.
Sorry, because like I only got the 2 points for P, which is -3 and -2, right?
Yep.
Can I just make my center points 0 and 0?
That's exactly right, because this circle is x squared plus y squared equal to 0. So it is in the center. You're right. At the origin.
Okay,
the center is at the origin. Yeah.
Yeah, thank you.
Right, everyone. We've got lots of answers. Well done. It looks like everyone is on track. So let's start. So yes, this was a much, I guess, well, not really easy. It was just a reminder that we do get circles with the center at the origin. So if it's x squared plus y squared, then the center is 0, 0, so it's at the origin. So we're going to start by working out the gradient of the radius. So just remember that that point is 0, 0. So we're going to go 0 minus 2 over 0 minus 3. That gives me 2 over 3. So that means our gradient for our tangent, we can just flip over the gradient for the radius. So that gives me 3 over 2 and change the sign. So it's -3 over 2. So I see quite a few of you got the 3 over 2, but you forgot about the negative 3 over 2. Okay. So we are going to sub in -3 and -2. So our gradient is -3 over 2x plus c. We sub in -3 and -2, and that's -2 minus 3 over 2 minus 3 plus c. Okay, and then we get, I'm just going to do this quickly on my calculator. I'm feeling very lazy. So -2 minus 9 over 2 is -13 over 2. So well done, all of you who got this right. -13 over 2. Okay. So for this section, you will always get a question about the tangent, the equation of the tangent and the radius and the circle and all of that. We're using 0 because the points that we are using for our gradient are here, 0, 0, and -3 and -2. You can also do it the other way around. Doesn't matter as long as you follow the same order, but yeah, that's why we do that, because our point is 0, 0 and -3 and -2. That's the points we use to calculate the gradient of the radius. Right, everybody. That's it from me this evening. Ms. Coco, I think there's a poll this evening. Is that right?